made the determination that we're just going to do all of this section in our notebook just because, okay, just because. So note 7 point, I'm sorry, I said 7.1, 7.3. 7.3 is intermolecular forces, that's INT. ER molecular. Okay, we can abbreviate this IMFs. These are also known as IMFs. Okay, intermolecular forces. And the first thing we need to know about intermolecular forces is what they are versus what they aren't. Okay, so what intermolecular forces are not? Intermolecular forces are not intramolecular forces. So there's two types, inter and intra. Okay, intramolecular forces. Well, let's just define inter first. Intermolecular forces. Okay, they take place outside of molecules. They take place outside of molecules, not inside. Okay. Take place between molecules. Okay. It's an interaction between molecules. Okay, that's intermolecular forces. Intramolecular forces is another way of saying bonding. Let's do this. Let's say intramolecular forces are, let's just call it what it is, ionic and covalent bonds. Okay, so when we talk about intramolecular forces, we're talking about forces within the molecule, okay, specifically ionic and covalent bonds, okay, and that takes place within the molecule. Okay, so we're going to focus not on ionic and covalent bonding, intramolecular forces, but rather intermolecular forces outside. You got to really remember that whenever we're studying this stuff. This is the forces taking place outside molecules. Okay, and the easiest one to start with, I think, is hydrogen bonding. Well, actually, there's three types. Let's talk about the three types. Okay, three types of intermolecular forces. IMFs. Okay, the first one is hydrogen bonding. Two, dipole-dipole. And three, London dispersion. Oops, ION. I hope you can read that. DISPERSION. London dispersion. Again, that's an ION. Okay, there's a reason I taught you polarity, polar, nonpolar first. Okay, it's going to make understanding this. Well, you have to understand that to understand this, basically. And let's go ahead and start with the hydrogen bonding. This is the easiest one, I think, to wrap our heads around. Okay, so let's go ahead and start by examining a water molecule. Okay, let's draw a water molecule and let's look at the polarity of this water molecule. Thinking back to the elephant and the tug of war. This thing is polar. We've already established that. Okay, and what that really means is this. It means that most of the time the electron's going to hover around this hydrogen. If the electron's hovering around the hydrogen, if you want to think about it that way, and let me clarify that that's not an entirely accurate way to say this, but it's going to work for this model. But if the electron's hovering around hydrogen mostly, then, and we know the electron has a negative charge, then we know a lot of times there's going to be more of a negative charge surrounding this oxygen. Okay, it's not a formal charge because this is still being shared between these three atoms. Okay, so it's never fully negative, but it's partially negative. And the way we indicate that is with this little lowercase delta sign. It looks like that. Let me pause, I'll get a better pen. I'll just draw it with the Sharpie. Okay, you're going to do this. Here's the symbol you make. It looks like that, almost like a figure eight. That wasn't a very good one though. Okay, like that. And you put a negative. So that shows that this oxygen is partially negative. And by contrast, we can say then that these hydrogens, since they're losing the electron to the oxygen, they're partially positive. And what this does is, well, we know that negatives and positives, they attract one another, right? These charges attract one another. So what happens is whenever you put a lot of these together, you're going to get an interaction that takes place. And I'm going to go ahead and actually, I have one drawn here. No, I'm going to draw a new one. I'll pause and draw a new set of molecules. Actually, let's define these. This means partial negative charge. And this is partial positive. Okay, and let's just write this in the notes. Because H2O is polar, there is an uneven sharing of electrons. There's an uneven sharing of electrons. This means that there's a partial charge. This means that most of the time oxygen has a negative charge to it. Okay, that's how you can think about it. That may not be 100% accurate, but that's how you can think about it. Okay, I'm going to pause because this is running way long and draw some molecules for you. Okay, here are some water molecules. And we said that this oxygen, it's hogging those electrons, so it creates this little bit of a negative charge. So what happens is the intermolecular forces, there's going to be an interaction between these molecules. It happens outside of the molecule. So it looks like this. That partial negative is going to be attracted to the partial positive, say, of this water molecule. And that partial negative might be attracted to this partial positive. And you can start to see how these things interact. And these right here, these attractions, these are called hydrogen bonds. Okay, these are hydrogen bonds. Okay, hydrogen bonding takes place between, it happens when hydrogen is bonded to oxygen, nitrogen, and fluorine. Okay, it happens when hydrogen is bonded to oxygen, nitrogen, and fluorine. You can get these hydrogen bonding interactions. So common examples. H2O is the most common. H2O, NH3 for ammonia, and HF, hydrofluoric acid. Okay, so let's go ahead and look at a real life model here. This is, oh, it's a water kit, 3D Molecular Designs water kit. Okay, so here's how this works. Look, these things are, they work like little magnets, right? Here are these water molecules, okay? And you can see these interactions here. I'm going to have this on my desk for this so you guys can kind of play with this. It's a really great model, and it shows how, look, this is a water molecule, but it's polar, right? It's polar. So it acts like a little magnet, and these two things, this partial negative of the oxygen is attracted to the partial positive of the hydrogen on this molecule here. Isn't that neat? Okay, so that's hydrogen bonding. Hydrogen bonding. I'm going to go ahead and make that the end. Oh, also let me just say this. Okay, we'll go and write this here. Responsible for high boiling temperature of water. Yeah, it's responsible for water's high boiling temperature. And the reason why is it takes a lot of energy to break these hydrogen bonds. Okay, these hydrogen bonds require a lot of energy to break. So that's why water has such a high boiling point, because it takes a lot of heat to get these hydrogen bonds to break apart in the water molecules to dissipate, or to turn into to vaporize rather. Okay, I'm going to continue this set of notes in the next video.